that are supported by European Commission in order aiming to improve packaging, the implementation of bio-based packaging, and new solutions of packaging for the food market. So we have today 3 presentations on this webinar. A first presentation about the recent trends of bioplastic on the current market. Then another presentations about what are the expectation of industry actors towards this new bio-based and bioplastic packaging. Then a presentation of an upscaling of bioplastic technology done by the project YPACK. And at the end, I propose you to have a general discussion, a general debate, and to ask your question in the chat, or if you have burning questions, we can take 1 or 2 questions after each presentation. So I propose to start now by the first presentation about the recent trends at market of bioplastic. So this presentation is done by Tatiana Pavlenko. She's belonging to the MyPack project. She's a researcher of University of Arnhem and responsible of Horizon 2020 project on bioplastics and innovative packaging technologies. So Tatiana, I give you the floor.
Thank you very much. I will share. So, can you see my screen now?
Yes.
Great. So,
Perfect.
hello everyone. My name is Tatiana Pavlenko from the University of Hohenheim. I'm working at the Research Center for Bioeconomy, and I'm involved in several projects, and one of them is a Horizon project, MyPack. One of our tasks in this project is to design specifications and guidelines associated to, among others, to the market of bioplastics. And in this presentation, I would like to give a general overview of the market and to look at some trends. But before, of course, I would like to shortly introduce the project itself. So MyPack project is about finding the best markets for the exploitation of innovative, sustainable food packaging solutions. And for this, we have several objectives. These are the promotion of the commercial development of biodegradable and compostable packaging, promotion of the development of packaging from renewable resources, and promotion of the commercial development of elaborated high barrier or breathable or active packaging technologies. So as I have said, in our project, we are designing specifications and guidelines, and to be able to do this, we work with several aspects, which are industrial feasibility, macroeconomic barriers, regulatory barriers, consumer aspects, and environmental barriers. Work and analysis in these directions would help to improve the market readiness and to find the best markets. We are a consortium of partners coming from several European countries. The project is led by the French partner Actia, and we have representatives from different parts of the value chain, which are material providers, packaging experts. Also, we have academia, so the partners who are involved in bioeconomy and consumer studies. We have end-of-life and life cycle assessment part, and of course the end users. And in MyPack project, we are focused on 3 food groups, which are fresh cut vegetables, sterilized baby food, and organic products. In our project, we are working on 7 technologies. Each of these technology corresponds to one of the 3 objectives that I have outlined before. From this table, you can see that technology 1, 3, and 7 belong to the objective development of bioplastics, which are biodegradable, compostable, or from renewable resources. The rest, which are technology 2, 4, 5, and 6, correspond to the objective development of elaborated packaging technologies. So this was a short introduction to the project and to our activities, and I would like now to start with general market of bioplastics. Of course, bioplastics are divided into bio-based, non-biodegradable, bio-based, biodegradable, and also there are plastics which are fossil-based, but they are biodegradable. And increase in interest in production of sustainable products, of course, increases the need to produce, when it comes to packaging, to produce bioplastics. For bio-based plastics, there is a number of plants which are grown to be used for the production. And this raises many concerns among public, especially NGOs, when it comes to growth of crops which are food and feed crops. And when they are used for production of bioplastics, this raises many debates. But as you can see from this figure that is provided by the European Bioplastics in the collaboration with Nova Institute, they're even taken into account the growth of the market for bioplastics in the next 5 years. Even by 2024, the share of the global agricultural land that is used for for growing crops for bioplastics will still account for around 0.02%. That is really less, and this is an obvious indication that for now we don't have a clear competition between crops grown for food and feed and crops grown for bioplastics. Also, in one of the latest studies published by the Nova Institute, there is data provided on the regional development of bio-based polymers. This is on the global scale, and from this figure you can see that after Asia having its 45% share in the production of bio-based polymers, Europe follows with 26%. According to projections for the next 5 years, there will be a drop in shares for all other regions except of Europe that will reach 31% share. And experts says that this will happen mostly due to the increased production of some plastics that you can now see on the slide, and also they name some casein polymers which are or will be produced only in Europe. Annual production of plastics in general, global production of plastics, account for around 359 million tons per year, and the share of bioplastics is only around 1%. However, the market is increasing, mostly due to the increased demand and appearance of new and more sophisticated bioplastics and widening of applications. So based on the forecast, until 2024, global production of bioplastics will increase from 2.11 million tons in 2019 to 2.43 million tons. When it comes to the share of specific bioplastics, biodegradable or bio-based but not and non-biodegradable, in 2019 more than 55% belonged to the biodegradable plastics, and the rest was bio-based, non-biodegradable. It is projected that by 2024 the situation will not change dramatically. It will be only a slight decrease by 0.1 0.5% for biodegradable plastics. Also, experts say that the growth in the production of bioplastics will be mainly led by polypropylene and PHA. In 2019, it was reported that polypropylene entered the market on the commercial scale, and its production is going to increase from 0.9 in 2019 to 5.3% in 2024. Another plastic that gets attention is polyethylene. It is predicted that some new production capacities will enter the market soon, so there will be also increase in the production of these bioplastics. As well, when it comes to polyethylene, PET, experts say that the projections will not be realized due to the fact that the interest shifted to the production of PEF that is not yet present commercially on the market, but it's supposed to enter the market in 2023. Regarding the biodegradable plastics, a lot of attention is given to PHA, and this will be, based on the estimations, the main driver for the increased production of biodegradable plastics in the next 5 years. Shortly coming to the production of bioplastics by market segment, in 2019, packaging was the biggest part for bioplastics applications. It was around 53%. Also, there are other segments like textiles, agriculture, and automotive. Based on the projections, by 2024, the share of packaging will still be more than 50%. I would like also to mention the European Bioplastics, that this is the association that represents the interest of the industry, and they have representatives from each part of the value chain from all around the globe, but they contribute of work at the European market. And I would like just shortly show you that there are members involved in renewable raw material and green chemistry. Of course, certification is important. Manufacturers, bioplastics manufacturers and auxiliaries. Then we have converters, just with some examples, brand owners, and of course the members involved in research. The main goal of the European Bioplastics is, of course, to promote the idea of bioplastics and its their contribution to the sustainable development of the society and contribution to a circular economy. There are a lot of debates around the potential substitution of conventional bioplastics, and experts said that in general substitution is technically feasible for almost every fossil-based plastics or application. So based on the study, in 2018 in the EU, packaging was packaging had the highest share for application of bioplastics, with the most popular polymers such as polyethylene, polypropylene, and PET. As you can see from this slide, the bioplastic share in this packaging is only around 1%. And here we can see the division. Mostly half of them were drop-in plastics, and of course other biodegradable and starch plants. On this slide, so it shows, it's also about the technical substitution potential of bioplastics. And experts say that bioplastics can replace fossil-based counterparts by directly replacing the crude oil feedstock by biomass feedstock, or by indirectly increasing the use of biomass materials. In the study, experts gathered data from several studies, also extended the data by opinions from experts to show just the feasibility, technical feasibility to substitute petrochemicals. So they assumed that 100 could be substituted. Just for you to better understand how to read this table is that, for example, if you have polyethylene, you can potentially substitute it by several bioplastics, like BOPE by 55%, PBAT by 10, and so on. So this is just the representation of technical substitution potential that was published in one of the latest studies. As well, the results demonstrate that in order to substitute European consumption of petrochemical plastics, there is a need to increase by 8.4 times in the global bioplastics production. As you can also see from this graph, for some bioplastics, this would mean increase up to 100 times. Of course, this is technical substitution potential, but such factors as economical feasibility and resource availability are not considered in this study. Yes, when it comes to competitiveness of bioplastics, the competition strongly depends, of course, on the policy support, oil prices, and feedstock prices. Current production costs of bio-based materials heavily depend on the feedstock. Of course, when bio-based materials are produced from the low-cost feedstock, the bioplastic could be quite close in its competition to the fossil-based counterpart. But when it comes to cheap or low oil prices, in this case, the competition might become quite strong. Especially, yes, the problem arises when you need to so when the plants are not designed to separate bioplastics, or when they are unable to biodegrade. In this graph, you can see the share of the production costs. This is in general for plastics industry, but the idea is just to show you that raw materials can sometimes take really a high really big share in the production costs, and this of course applies to bioplastics. And if the price for the feedstock is quite high, this might have big influence on the final price of the product. Shortly, I would like to mention some challenges that exist in the on the market of bioplastics. Of course, bioplastics have to compete in price with fossil-based counterparts. There is a need to guarantee an availability of bioplastics. There are problems arise around the recycling infrastructure, and also when it comes to sustainability, there is a need to see that bioplastics offer advantages in terms of material use and longevity and end of life. Of course, there is a need to guarantee that the proper end of life solution is chosen. As a separate challenge that I would also like to mention is that there is an increasing trend for packaging-free products that also contributes to decrease of plastic pollution in the environment. But however, there are some points that should be considered. Because packaging means free packaging means that there is a lack of information on ingredients and shelf life. Packaging offers better storage, safer transportation. When we talk about packaging-free products, hygiene should be considered and durability, of course. And packaging is used for labeling, and this is an influential marketing instrument. So the current economic reality prevents from really replacing chemicals used in plastic production by biotic feedstock, but of course there are already some cases when bioplastic can be competitive, and especially with economies of scale, learning curve effects, and policy stimuli, the situation might improve. As well, there are some market drivers. In general, this is increasing demand, development of innovative materials, and continuous research in the bioplastics industry. And this is my last slide. I would like to underline that for MyPack, especially biodegradable and compostable packaging is very important since we have a strong focus on developing such packaging. I will not go into details that much on this slide since there is the next presentation that will provide more insights, but I would like just to mention shortly that for us it's important to understand that there is a need to establish a dialogue between different members of the value chain, and of course an important part is the regulatory framework that steps in policy are needed for development of new regulations. For example, as you can see, the already existing standard that defines requirements for packaging to be eligible for industrial compostability. Yes, and with this I would like to close my presentation. Thank you for your attention, and if there are any questions you can ask or just yeah, leave them in the chat and we will answer them. Thank you very much.
So thank you very much, Tatiana, for your very clear and nice presentation, this overview of the situation regarding the market of bioplastics in Europe and in the world. So we can take one or two questions if you want. I'm just checking in the chat if we have. No, yeah. Somebody wants to ask a question. So it seems when we see when you listen to you, when we see your presentation, that the competition is quite important with fossil bioplastics. And then these fossil bioplastics are developing more and more. We see that in the future, the production of polypropylene, polyethylene will continue to increase. So it will not be easy for the implementation of bioplastic in the market.
Yes, but I think with Europe's efforts to improve the circular economy and establish new standards, we just need to have proper collaborations and more dialogues in this direction, because there are many drivers that also comes from the consumers side. Also brand owners want to present their sustainable products. So I think we are in the right direction. We just need proper collaboration and support, especially from the governments, so that the companies companies that commit themselves to produce some sustainable products, that they also gain from this, and they understand that they have benefits for themselves, for the company from one side, and of course this has the benefits in general for the society and environment and so on.
Yes, I think there are some drivers that we have to push for the implementation, and many of them are, of course, consumer expectation. Some examples, adoption by big companies, to give an example, to give examples. Policy, of course, regulatory aspects in Europe and so on. So, if I see the chat, something should be done to increase the availability of recycled PLA, even post-industrial, for liquid food types, soups, for example. Are there any differences in the packaging to be adopted? So I don't know what.
I'm not sure if I understand this
question. It's not very clear. So I propose to go to the next presentation now. So I invite, we have a common presentation by Denise Guider and Sofia Kertész from GLOPACK project about the expectation of industry actors regarding this bioplastic packaging. And we start, I think, by Denise. I can introduce both of you now. So Denise is coming from EcoZept. EcoZept is a partner of GLOPACK, and she's responsible of projects on the circular economy. And Sofia is working for Camden BRI Hungary, Camden Food, and she's a development engineer. So both of them will introduce this part of the webinar, this presentation about industry expectations. So I give you the floor now.
Okay, thank you very much. Can you hear me well?
Yes.
Perfect. So a warm welcome to everyone. We look very much forward to be part of this webinar. So thank you also very much for organizing it and bringing the three projects together. Today I will focus together with my colleague Sophia to talk about the expectation of industry actors regarding bioplastic packaging. So I will mainly start by introducing our market analysis results, which EcoZept conducted together with our French partner Symmetres, and then Sophia will take over to derive recommendations for stakeholders in the food packaging sector. First of all, I would like to very briefly introduce the GLOPACK project to you. So GLOPACK stands for Granting Society with Low Environmental Impact Innovative Packaging. The project aim is to develop fully sustainable food packaging solutions, but not just to develop them, to also test them at different stages of the value chain, for example, also including a market replication, a quasi-market replication, and also a focus of the project is really to develop a stakeholder-driven business plans for the solutions developed in the project. So we are a consortium of 16 partners from 7 European countries. We have a look at 3 packaging innovations and software. I will briefly introduce on the next slide. Then we have 3 value chains we have a look at, as well as 1 stakeholders platform. So one of the innovation that is developed is a food packaging based on PHA, which are based on agricultural and food wastes. And these kind of packagings, it's a cup, it's a tray and films that are biodegradable under home compost conditions. We also focus on other types of innovations, which is active packaging, also intelligent packaging, where we have a look at a battery-free radio frequency identification and a biosensor to detect food freshness, as well as a decision support software to support decisions based on different criteria, including cost and environmental sustainability. But as our presentation is only focusing on bioplastics in this webinar, I will also just present the results regarding this innovation. So what we have done in order to collect the expectation of experts, we have conducted multi-stage iterative interviews with European packaging experts. We conducted overall 3 rounds of interviews. We overall had 69 in-depth qualitative interviews in 2 rounds. And to validate these qualitative interviews, we also conducted an online survey. How did we define packaging experts? As we also have a large varied spectrum of innovations we have a look at. We also had a wide spectrum of packaging experts interviewed. So we had a look at, we interviewed food manufacturers, retailers, packaging companies, converters, polymer producer, consultants, and other companies and institutions. So regarding, now I already come to the main core results. Regarding the driving forces, so for the experts, there were 3 main driving forces. The most important, so on the one hand, the society's increasing concerns for the environment general, as well as for packaging issues, which become more and more important. Also regarding the consumer's behavior that purchase more and more like green, sustainable food products, and then also packaging is also becoming more important regarding this, as well as the legislative changes by the European and national institutions. If we have a look in depth more into experts' perceptions, so, and this is also fitting very well with the first presentation of MyPack of Tatjana today. Costs were seen as the major market barrier so far for bioplastic packaging. And in this context, the experts also expressed doubts that consumers accept higher prices for the food product. Then regarding the functionalities, there was also the perception that market available solutions would be inferior to fossil-based solutions. However, as we have a broad spectrum of bioplastics, and this of course really depends on applications. And they were partially also incompatible with existing packaging lines, which means new machines or adaptations would be necessary. This, of course, again, depends on the application regarded, but this also was an important challenge. Regarding the waste management system, it's like right now regarding market available biodegradable plastics that they need really specific conditions to fully biodegrade, and that some of the bioplastics are not adapted to the waste management and sorting systems. But this again also depends on the applications regarded. Then regarding the environmental performance, in general, bioplastic were perceived more environmental friendly. However, the ecological footprint is not per se lower than for currently used plastics and has to be proved. It can provide better end-of-life options. However, this depends on the application and the infrastructure, of course, of the region. Then one additional core point was also regarding the application knowledge. A lot of experts expressed that bioplastics are sometimes more difficult to understand or use. This again depends on the application, but a barrier was also that sometimes special expertise is needed also regarding challenges of finding appropriate suppliers, not just regarding volumes, but also the quality. And they also mentioned that making tests regarding trialability is also not so easy, as well as not a lot of solutions can be seen already on the market. So also observed limitation here. Regarding sourcing, there was also not sufficient quantity and quality mentioned by the experts as one core challenge right now. So here we summarize the results regarding an analysis of market competitiveness. So if we have a look at threat of new entrants, this is really influenced by limited availability and quality of the material, special training need for employees, higher costs, and economies of scales have not been reached, as well as the core point that high benefit have to be perceived by consumers. Then regarding threat of substitute, currently used packaging has still several advantages from experts' point of view, which I just pointed out on slide 7 and 8, so there are also large limitations. Here again, regarding bargaining power of suppliers and customers, sourcing sufficient qualities and quantities is still challenging, but the market is not yet mature enough that actors along the value chain have any particular market power. So overall, the industry rivalry is still rather low due to the low market share. So what can we conclude out of this? So as you have seen, there are lots of still existing challenges as core part of setting up business plans and marketing strategies. So this is a core point to be regarded. The bioplastic packaging has to be really integrated in a whole strategy for companies. New cooperation of actors along the value chains are really needed, and also investments need to be conducted. And we regard also the communication strategy as a key success factor, but also think that further development of market available solution is necessary regarding the end of life that has to be considered, not just what is the possibility, but also the infrastructure, as well as waste management processes, and that research and development for material is necessary, as well as upscaling, where the third presentation will also deal with. So now, if Sophia is there, she will soon take over. I thank you very much and look very much forward for your questions. And I will now give the floor to Sophia.
Thank you very much. And I also welcome you all. I hope you can hear me well. So from the rest of the presentation is focusing on recommendations for the different stakeholders. We
do not hear you very well. Sophia, if you can perhaps improve the sound.
I will try. I don't know what to do. But
it's not very, very good, but we hear you, of course, but if you can improve the quality of sound, it would be nice.
Okay, maybe now. I don't know.
Yes, it's better.
Oh, cool. So, sorry for this. So within GLOPACK
Speak
project,
loudly.
Okay. So within GLOPACK project, we developed the position papers, which focusing on the benefits of home compostable and biodegradable materials for sustainable food chain. Next slide, please. And this position paper includes several recommendations for policymakers, for the industry, and for consumers as well. Next one, please. If we start with the recommendation for the policymakers, the first set of recommendations aim to reduce the consumer confusion and provide greater transparency. We already mentioned, the first presentation already mentioned that The change in the regulatory background and revising the labeling requirements on food packaging would be essential to aim to achieve this. As for example, you can see some packaging where the labeling says, okay, the packaging is compostable, but there is no indication whether it's home compostable or it should be compostable in an industrial facility. The same goes with the term using sustainable packaging. We all use this term, but sometimes for the consumers, it's not very clear what does it mean. So this kind of clarification would be very advisable from our point of view. Also, the general
please, Sofia, I have some people wanting to hear you better. You cannot speak
now it's better.
more.
I removed wireless.
It's the same. You cannot improve. Just perhaps your micro on, yes.
Okay, is it better now?
It's perfect now.
Okay, shall I start over? Somebody said yes. So Dennis, can we move back one slide, please? Okay, so in the position paper we developed in GLOPACK project, we formed recommendations for the policymakers, for industry, and for consumers. Next one, please. The first set of recommendations aim to reduce the consumer confusion and provide greater transparency. As it was mentioned in the first presentation, the change in the regulatory background and the revision of labeling requirements on food packaging would be quite beneficial. For example, you can see packaging saying that the packaging is compostable, but there is no indication whether you can put it in your compost bin at home or it should be composted in a facility, an industrial facility. The second point is that the general practice of the collection, the sorting, and the recycling of certain packaging can vary from country to country, and also sometimes they vary within a country. For example, in the UK, Dennis, next slide, please. For instance, in the UK, there used to be, or still they have three categories regarding the recyclability of the packaging. So first, you either can recycle it or not, but there is a third category saying you should check locally whether your local authority is able to collect that certain packaging or not. Next one. But as it was announced earlier this year, in the UK, this whole system will change, and basically there will be a go, no-go decision. So either you can recycle your packaging or you can't recycle it, you shouldn't do that. In this way, it's easier for the consumers to make a more sound decision. Next slide, please. The second group of recommendations will focus on the possible directions of future researches. We know there are some standards available, but future standards should be developed about, for example, the biodegradability in the marine environment, and also further environmental impact assessments should be performed of each plastic type in order to understand the whole system better. We all mentioned, Dennis mentioned, that Tatiana also mentioned that collaboration is key, national and also local level, and financial and other kind of support would help the industry to move towards using sustainable and innovative packaging. Next slide, please. So here we have the recommendation for the industry. The first and one of the most important is the active communication and promotion towards the consumers on the benefits of the new type of packaging materials, on reusing plastic waste and food waste as well. Furthermore, one of the key hampering fact that not using sustainable packaging in the food companies is that they are lack of knowledge, they are lack of experts within a companies, especially SMEs, so they would need further help, further guidance. This is why in GLOPACK we developed the decision support system. Next slide, please. This decision support system will help the companies, the users, to identify an optimal compromise between the requirements of the food, the market, and the consumers. And also another key element, in our opinion, is the training. So we have these tools, we have any kind of support for the companies, but if they don't train their staff, they won't be able to exploit these new opportunities properly. Next one. And lastly, we reach the consumers. They are one of the key as they can be a driving force. Currently, there is a lot of confusion around the topic of sustainable packaging in their mind. They don't really understand the terms, what they should do with this kind of packaging. So for them also training would be beneficial, but maybe training is not a proper word, it's not the proper description of this activity. Maybe direct communication and promotion. GLOPACK was involved in a quite good program or task led by the BioVoices project. Together with the lead of BioVoices, we developed online educational cards. You can see 2 examples on the slide. Most of them are very visual, very easy to understand, explaining the basic definitions of the biodegradable, bio-based packaging. And in this way, we can easily reach consumers, we can target them, as they can be shared on social media. Next slide, please. So just to conclude, we all know that we have a common goal to tackle the plastic pollution, and this is why we also developed this position paper to provide additional help and a summary basically on the problems, and this is why we formed the recommendation of for the stakeholders. And also we mentioned several times that the collaboration is crucial, and this is why within GLOPACK we operate a stakeholders platform, which aims basically to achieve these dialogues between the different actors of the stakeholders. And if somebody would like to join our stakeholder platform, please just contact us and we will make that happen. And I would like to thank you very much for your attention and apologize for the technical issues.
So thank you very much, Denise and Sofia, for this very, very clear presentation. If we can take 1 or 2 questions. Burning questions now. As you are insisting on the training sessions, on training activity. You mentioned that it's important to train people to adopt for the implementation of bioplastics, but my question is, who is able to provide this training? This technical training, this, I would say also economic training?
Our plan, that as our consortium has a lot of experts from with different background. So as our project approaches its ending, we will develop a training course for the interested parties. And those, of course, we will take into consideration the technical aspects, the economic aspects as well. So in this way, we can develop like a training package, if you would say, considering everything you would need to know, or at least with some basic information, basic background on this topic, which might help the users to start, or if they can't start, they will have some contacts to reach out and do the actual development.
If I can add very shortly something,
yes.
This also, of course, depends on what kind of innovation we are talking about. I mean, packaging companies offering these kind of solutions, they are like a key point in order to like support the brand owners in adopting these kind of innovations. And it has to be totally adapting to the existing packaging line. So we also see like packaging companies that offer these solutions, that they have a core point also in order to give additional services in order to, for example, support their already existing customers in order to adopt it. But this should be seen as an additional point to be regarded, not just offering it, but also supplying like more consulting aspects into that, because it's not always that easy to just use the new material. Temperature has to be regarded, speed has to be regarded, so it can become quite complex. So this is really an urgent need to face this as well.
Yes, and you are mentioning that sometimes you have to change the processing for the fabrication of the material, of the biomaterial, the biopackaging. You have to change the equipment. You have to. It can be a challenge for a producer of packaging. No.
Yes, I totally agree. It can be a challenge, but I think with like more precise information, what it can, what it cannot, what has to be adopted, and like a clear communication about that, I think it can also give a clearer point on what can be expected and what not. Because what we perceived in the expert interviews was sometimes a lot of frustration or dissatisfaction regarding material because it didn't work as it should have worked. But I think with a clearer communication on what can be expected and what is needed, but like with good support, we think it will still be feasible.
Yes, and also the communication towards consumers is also important, because I think it would be important to find on the food products not the composition of the nature of the packaging and how it can be composted, how long it will take to be completely destroyed, completely degraded, and so on. What do you think? Yes, we have to improve this communication also to consumers.
Yes.
To invite him to buy product with bio-based packaging.
Sophia, do you want to answer, or should I?
You can start and I can add my points.
Yes, I think there needs to be a communication improved, but there's like so many things at the same time which have to be improved. Like there has to be like infrastructure where it makes sense that the end of life is going somewhere or it is established. And we should, of course, improve the communication also to make it more target oriented, but we should also not forget that consumers have a very limited capacity in order to understand all kind of labels which are already on the packaging. So I think there's a huge potential in like better communicate about it, and also to better make clear what it means that it's bio-based, what it means behind it, because it's not always very clear to consumers what it means. We have to really find proper names and a clearer understanding, and this is why I think it's also so important to, when it's developed, to think about what can be communicated and what is quite challenging, and where do we need like additional information in order to make it comprehensible, which cannot necessarily fit on the packaging, but there is a broader scope also needed for that.
Yes, of course, we have to adopt a very clear and simple message communication for consumers. Okay, I have a practical questions regarding the availability of presentations. The presentations are confidential or not? They can be disseminated.
From my part, they can be disseminated. How it is with you, Sophia?
Yeah, okay. For me as well.
Okay, so for all the auditors, I think the presentation will be available if you want. Another question regarding GLOPACK, where auditors can find the one page the GLOPACK has developed.
I will send the link in the chat.
Okay.
And after that, I can send you, Christoph, the link, and you can share with the participants after that as well. It's not a problem.
Okay. So thank you very much for
Thank
this
you.
very nice presentation. So now we can move to our last presentation done by José María Lagaron about upscaling of bioplastic technology. So José María Lagaron is a group leader and founder of the group Novel Materials and Nanotechnology. He's working in CSIC in Spain. So Kema, I give you the floor, and I'm happy to hear you today.
Yes, thank you very much. Good morning, everyone. It is great pleasure, in fact, to be with MyPack and also in the company of GLOPACK for the second time. I think this is the second event that in which we joined the two projects all together. So thank you also the organizers for allowing us to show what we have done within the YPACK project. A lot of pack. I will share my screen now. Hopefully it will work. Can you see my screen?
Yes, it's
okay,
perfect.
Very good. So YPACK. YPACK is an innovation action that occurs like every European project, is the result of a very fruitful international cooperation between different actors. It's coordinated by our team within the Spanish Council for Scientific Research, Institute of Agrochemistry and Food Technology. And in fact, it is, as an innovation action, is a very much focused in one of the things that over the years, we've been working in developing bioplastics, etc. And always the same question that we got asked is, but is this technology scalable? Can these products actually be scaled using conventional industrial machinery? And that is what YPACK is all about. It's about meeting together a number of key partners. There is a noise at the background.
Sorry for that.
Okay, but I'm being heard, correct?
Yes, we can hear you.
Okay, very good. I'm sorry. So I was just saying that we are taking advantage of the knowledge that a unique number of partners across the food chain, because we start with people who is actually collecting food waste, and companies that benefit from this technology, that are actually commercializing some of these products, or that are dealing with them. And then we use them with companies to scale up production of the materials that we have used in the project. And then eventually there is a number of partners that will scale them up once the formulations are being optimized. So in fact, most of the technologies that we have started with were already developed at a lab scale. And what we did is to show the feasibility of taking this into a production scale and testing the produced products that I will show in a minute by retailers into their shops, so that consumers could actually have the experience within their hands of taking our packaging, compare this with other packaging around. And there is, of course, life cycle analysis, dissemination, and we thank very much, for instance, UFIC, which has been helping, it's been paramount to disseminate the results of the project, etc. So what are the results and the lessons that we have learned over this 3-year program of research? well, that's me. The title, then I will try to answer that question. So the title of the project was to minimize food waste by applying high-performance biopolyester-based packaging. So our packaging is based on a very unique biopolymer, which has been as the target of a number of previous EU projects in which we and other partners around the table today have been involved, sometimes together, sometimes in separate projects, but all with the same idea of really taking this biopolyester from a microbial origin into a production scale. So we know that probably these kind of numbers have been presented before, but because I joined a little bit later, I don't know exactly what is being presented, but we know that today the circular economy strategy is all about mechanical recycling, which unfortunately only 31% of the waste is being recycled. We also know on top of that that 1/3 of every food or of all the foods being globally produced are actually wasted. And this is a staggering figure. And then on top of that, just to set the scene for our project to join in, and then on top of that, we know that about 8 million tons of plastic, they end up into the environment, into the sea in this case. So all these environmental disasters are right now as a vivid into the minds of the consumers, and they are demanding action. And this is what is being going around for some time already. And there has been many cycles for the circular bioeconomy strategies over the last years, but I think it's already the time for these technologies to also offer an alternative to this as a solution to the circular economy strategy within the context of what we call the biocircular economy. And I will present that in a minute. So what is the YPACK product flow? So we start with raw food-based industry byproducts. So these are byproducts that today are being created. Some of them are valorized, some of them are not valorized to a sufficient extent. It is true that they have a value. And I don't want the audience to actually get fixed on the selected elements that we have used in the project, because this project is in fact a demonstration project that you can actually take waste, valorize it, convert it into performing materials, and bring this carbon back to soil. And this is what the project is all about. So we take some raw materials that we know that they are standardized to some extent, so the reproducibility is there. We converted them into films and thermoform trays, which is a very challenging technology for this type of biopolyesters for some years. We have implemented them with also some active solutions, antimicrobial, antioxidant, oxygen scavenging, etc., with the idea of adding additional value. Eventually, we have also done the life cycle analysis and product validation with the intention to bring them back through an organic recycling strategy, alternative to mechanical and chemical recycling, back into waste, so that we can have the circular bioeconomy concept close. So the main objective of the project is being the scaling up and validation of these technologies that we have developed. And the components that we have used to achieve all these challenging properties that we aim, because we were not only aiming at really generating packaging that looks nice, or that can be used for let's say, not preservation demanding products, but to be able to really reach the properties that today some of the foods are demanding in terms of shelf life. And we're talking about high barrier, we are talking about shelf life extension of fresh pasta, etc. So today, some of the people that have been using our packaging in the project, retailers and food companies, they are using all this high-tech packaging produced from petroleum-derived plastics. And in the near future, we hope that they will actually abort or they will take over some of the solutions that we have developed. Again, with the intention of closing the circular bioeconomy concept, so we've been doing biodegradation studies in different environments, not only industrial composting, which is fulfilled, let's say, by most of the existing biopolymers, but the most demanding biodegradation scenarios for end life that involve home composting, soil biodegradation, and marine biodegradation. In fact, we are now having some of our products hanging somewhere in the ocean, in the coast of Alicante, and we are just following in situ how this packaging actually evolves over time. So the key to success that we devised for this project was in a way supported by the fact that we were doing all the analysis that I will just mention. We started doing consumer profiling and market trends, concept testing and product validation. We are, of course, supported from a regulatory viewpoint by a partner that is being also assessing and issuing food contact status for some of the materials that we develop, because we do have products that are now in the market thanks to the effort that all together we have made. Risk analysis, and then of course techno-economical feasibility assessment of the packaging developed, and then the commercial rollout of it, which is right now where the project stands, is the current state of the project. So in a very, at a glance, we have developed a thermoformable tray, starting from a cast extruded film of about 600 microns, as you can see here. This has been converted into actual trays, which are thermoformed with the same machinery and with the same molds or similar molds, with the same size, thickness, width, etc., that currently some of the retailers use. And we developed 3 technologies. YPAC2020, this is a completely ready to go to the market food contact compliant product. YPAC25 contains a residue from almonds that will actually give the color, the brown, the typical brown color of the products that we have developed in the project, which retailers love and also consumers. And YPAC27 is the first attempt to substitute commercial PHAs, which is the polymer that we have been using, and I will describe that in a minute, by our own PHAs. PHAs that are derived from cheese whey residues from the cheese making industry. Again, don't just hold on these 2 specific wastes that we have used, because again, this is a demonstration project. We have done the same with municipal waste, we have done the same with fruit waste, etc. Carbon dioxide. So this material, I think, in our view, is the material of the future, because we can produce so many different grades with all these different properties, and by combining them, our intention is to be able to reach those applications. Eventually, of course, you can have in the industry or in the packaging industry, you have flexible, you have rigid, and we also develop some flexible film in the form of monolayers and in the form of high barrier multi-layers. And that was a very big challenge, so that we would be able to generate a film with the same barrier properties of polyethylene, EVOH polyethylene in terms of oxygen. Of course, we also develop active packaging solutions, but we decided not to scale them up because of the fact that the active packaging directive has never been really put into practice within Europe. So there is no positive list at the moment that we can use, and therefore we decided not to scale that because they would not have food contact status, and therefore it could not go into the shops, into the supermarket. So the first message to take home is organic recycling packaging is possible and aims at starting from waste, valorizing this waste, and back to waste. So we need to find ways to bring back carbon to the soil. And that is the strategy behind, the philosophy behind our biocircular economy project. Now, I will explain you very briefly. Antonio Vicente was supposed to be helping me out with this, but unfortunately he could not join today, so I will take his part. And in this part, what we're trying to very quickly explain to you is what we have done and what are the challenges that we face when we try to industrialize these technologies. So again, the model elements that we chose was cheese whey, because it's a standardized way of waste. Almond shell residues, which today are being used for some, let's say, not so relevant applications in terms of valorization. These two products are today have been licensed to some companies for commercialization, which are now trying to get them approved by the EFSA as food contact materials, or I mean, in the end, the materials are already in the list, but not the way in which they are being processed. So they are being assessed, and hopefully they will also join the YPAC25 and 27. They will also join the family of those materials or solutions or compounds that we have developed that will have food contact status, as well as YPAC23. The film has also got food contact status, by the way. So we had ingredients. We know that the components biodegrade even in marine environments. And what was missing was to prove that existing technologies today within industry were able to tackle them, so that we would prove that about 4-5 ton quantities of mass production into that amounts could be possible, could be viable. And this is what we have done. We have been able to actually manage to produce about 4 tons of these materials, which have been converted into these different packaging items that I had just described. So technology to achieve that was underpinning, let's say, the project. Okay, so the challenges were the upscaling of some of these elements and the processing in existing facilities, because as somebody mentioned before during the discussion, if you have new solutions and they require tailor-made processing equipment or facilities, then the implementation is going to be much more difficult. So our intention has always been to use the industrial facilities existing within some of our partners. And in fact, this is what is being done, right? It's been done in traditional industrial lines for casting, for thermoforming, for film blowing, etc. So the biggest challenge, in fact, has been to scale the production of the polymer, right? The polymer that is at the base of all the packaging that we have done. Because this has never been produced at such a scale as we have done in the project, and we have proven that is feasible. In fact, so the idea was to extract and purify PHA at a pilot scale, or the large pilot scale, because I think over 200 kilos of the PHA was produced. And with this, we demonstrated that we could substitute to some extent the existing commercial polyhydroxyalkanoate grades that are available. So we, of course, needed to compound the products so that they were able to thermoform. Injection molding is easy to do. for PHAs, but thermoforming was very difficult. So we really had to do a lot of work here of identifying what components that would fulfill our strategy of circular bioeconomy would have to be available at an industrial scale with a food contact status, etc., so that we could use them to do what I will show here. Establishing also the processing window. There was a lot of processing optimization needed to be able to get this extruded rolls or this film blowing process, etc. Eventually, the films were developed with monolayer and multi-layer high barrier with nanocrystals of cellulose coatings acting as the high barrier elements. We developed these very nice trays in these different concepts. And so the message is that YPACK was able to develop fully biodegradable in terms of biodegradable in the environment, which is what currently is being assessed, but we know that it works. So they are biodegrading in different environments, in soil and in the marine environment. We have also tested already and know that they biodegrade under home composting and industrial composting. And yeah, so what we developed was this barrier film and trays, so that combining them, we would be able to tackle a number of food products and at a large scale. So thank you very much for attending.
So thank you very much, Kema, for this very clear and nice presentation. So I realize that you have very good results, very good outputs from YPACK. So it's European Commission can be happy of that. And so I think we can start the debate with all the participants to this webinar. I had just to introduce these discussions. One question regarding the composition of the raw bio-based material. How do you harmonize it? Because it can be very different from depending on the composition. And do you have a strict composition of this? Because the properties of the material, of the packaging material can be different if the raw materials use, the quantity of is different. No?
Should I answer?
Yes.
Okay.
Well,
yes, that is exactly the challenges that we encounter. Yes. First, reproducibility from batch to batch, if you want. How to harmonize that, how to detect this so that we would modify the blending elements and recipes to account for this variation. But this variation, of course, is just the result of that there is no standardized industry behind. I mean, we're using mostly SMEs that are scaling the processes, etc. But you know, to polyethylene, it's been 200 years around, and they're still optimizing some products. So this is something that at least we were able to identify what the issues were. We solved them, and by using, let's say, commercial components today, the packaging can be made and is day in, day out the same grade. But eventually, of course, these new, let's say, ingredients, these new components will be replacing because they also lower cost, they have versatility in properties. So there are a number of attractive things that is recently scaled, let's say, ingredients offered to the solutions.
Okay, thank you. If I read the chat, I have a question from eFost. I think it would be nice if you could, I don't want to read it, but perhaps you can ask directly by opening your micro, please. It's about possibilities to
I
recycle.
can see a question of how much temperature your products for hot food packaging with a stand. So the HDT of the materials that we have developed are 110 degrees C, so up to 110. So pasteurization is feasible, even retorting in some cases. In our case, sorry.
A question for PHBV, is it okay for home compost certification?
Absolutely, yes.
And if yes,
correct.
for which thickness?
This is an interesting question. We have tried 600 microns, and it has actually worked under industrial composting. The home composting, I think it was made in the pellets. I need to confirm that, but it should be equally okay, I would say.
Okay, a question regarding microbial and enzymatic screening during the biodegradation of the raw materials.
Yes, we are. We're doing this with a research group that is annexed to our team in a university, and they are doing all these specific studies on the quality of the compost that is produced, and etc. And also which microbes are the ones that are more active. So this is a very nice piece of work with also not only in vitro but also actual in the field studies, where we bury in the sea some of these trays and films, and we are following them with divers every 2 weeks, how they actually evolve over time. And we see that they are biodegrading kind of slowly, but this is working, even in cold waters.
Okay.
I'm sorry if I'm taking over some of the questions for other people. I'm not sure if they are coming to me or to my colleagues at INRA.
Yes. One question regarding the material: is it also usable for
speak loudly,
liquid?
Please.
Yeah. Is it also usable for liquid food packaging solutions? So I'm not talking about the short liquid solutions. So for yogurt or something like this, do you also have experience in this with this material, or have you taken it in account?
Are you talking to YPACK or GLOPACK project? Are you asking me, or you're asking
to MyPack solutions? Okay. Yeah, because I saw that also the company HIP is working within this topic, and I'm asking if there are also, if you are working on solutions that are working for liquid solutions here, so that the material is usable for liquid applications, liquid food applications.
If I speak for on behalf of MyPack, we didn't study any liquid application. If somebody from MyPack wants to say something.
As far as I know, also we have salads, baby food, and some biscuits, so but not real liquids.
Yeah, regarding
okay, so it's pumpable food and not liquid food, so it's pumpable if you talk about baby food, or is it a baby food like snacks or cereals or something like this? Okay.
If I can add something, in GLOPACK we don't have a look at liquids, but one of the case study product is fresh cheese, which is regarded in an injection molded cup, and there we have a look at it, but it's fresh cheese next to like fresh meat, as well as ready to eat food, which is falafel. But I think this is also a very interesting application to further have a look at, but then there might be an interaction between, like this has to be closely regarding the material what kind of liquidness is acceptable, but I don't have any expertise in that, sorry.
Okay, thank you.
In our case, we did not do any liquid packaging, but as far as I know, is kind of okay with the exception of olive oil. I think olive oil, for some reason, we had some global migration that was exceeding slightly the limits. But for the other food simulants that we use, it was all okay.
Okay.
In fact, we use pure olive oil. So if you actually consider that some of the grease foods do actually have a fraction, so you multiply by a factor to bear into account that you are not having 100% an oil-based system, then for most greasy, let's say, products, then we are okay. Not for just pure olive oil. The rest was fine. The rest of the simulants were fine.
Okay, perfect. Thank you for this.
We have an optimistic questions about, I think it's for YPACK. Is your production capacity possible to supply India? I think that it will not be very easy.
Right. Yes. Now you can export. You can move goods. You cannot move people, but goods are still movable. Let's say, even in the pandemic. It's not that we have done so, but it is the companies that have taken the license for this technology and that will bring that to the market. Then their intention initially is, while the retailers are actually doing their job to take them up into their shops, which they are currently there. They are in the shops in Turkey and in Portugal, so that people can actually have the experience of taking the packaging home. The one that is, of course, food contact. As the company that has licensed the technology, the intention is to put this as within an electronic shop, so that you can actually, anybody could actually buy and get shipped to, if they would like to have these products. So at some point they will be available through an online electronic shop.
Okay, there is a polemic questions about the possibility that bioplastic becomes a polluting product for the planet. Who wants to answer?
I mean, how can that be? We take waste, we bring that back into waste. So we actually take the carbon, we convert it into a product that can be valorized, that eventually goes back into carbon. And then it converts into carbon dioxide, water, and good compost material. So this is really the nicest scenario possible, according to our view, that you take waste and you bring it back into waste, and in the middle has served the purpose of helping the food not to be lost. So I don't see how these would become the polluting products of the future. I think the polluting products of the future are still and are going to be mechanical recycled petroleum-derived plastic, which will be forever. And again, even in the perfect scenario where where the mechanical recycling works, we need to bear in mind two things. The same way as our packaging is not designed to be recycled, because it is counterintuitive. The traditional plastics derived from petroleum, which are inert and they are here to be forever, they cannot be recycled mechanically either, because they are not designed for that. So plastics, as we know, they have two issues. They stay forever because they are inert, and the second thing, they cannot be reprocessed more than a number of times. For instance, PET cannot be reprocessed more than 7 times before it creates food safety issues, migration, toxic components, etc. So we know that mechanical recycling is the current solution, but 31% of the packaging goes into the environment anyway. So even in a perfect world where this this mechanical recycling works, we are still sending plastic to the environment. So this is, to me, not a sustainable solution in any of the two forms, because when you reprocess, you will get some contaminants at some point. So you don't know when mechanical recycling is taking over in general, then who will guarantee to me as a packaging producer that every pellet that comes recycled will actually has not been reprocessed more than 7 times? This is not sustainable. So our strategy is sustainable, but there are other issues that need to be resolved, of course.
I think from a general point of view,
are there possibilities to recycle?
Sorry?
Are there possibilities to recycle the PHA-based plastic?
Yes, the possibilities for recycling plastics, to me, that work is the chemical recycling, which is at the infantry now. It's probably a 10 years away technology. The chemical recycling, which we take the materials, we break them down into monomers, we bring them into the synthesis vessel, and then we produce again the polymer.
If I can add into that, into the chat, I just added a project which is exactly looking also on this issue on recyclability of PHBV. I can highly recommend to have a look at this, because in GLOPACK, we don't have an in-depth look about the possibilities of recycling, but of course, what I think is very important also to add, to also always have a look at for which kind of product is it most urgent to also have this end of life of biodegradability, and also always to have a look at where is the value added. If you have a look at, for example, packaging of fresh products, where in the sorting it cannot be cleaned in that way in order to make it recyclable. So I think also these kind of issues should be taken into regard of like where this kind of packaging can have an additional benefit, where is it really urgent to find solutions in order to decrease the pollution. And I think this is a very important starting point to have a look at where is the most urgent need for this kind of packaging.
And on the general point of view, I can say also that if you want to have a complex packaging, bio-based complex packaging, if you want to add functionalities, you must, of course, add sometimes additives, and these additives can create a problem regarding biodegradability and composting. It's important to point out this problem, in my opinion.
Mm-hmm.
If you see, for instance, the packaging schema that you propose, a film that you are proposing, that you propose is not very transparent. Do you, on your opinion, is it a problem for the consumer? Because sometimes the consumer wants to see the product, to have transparent film, and but to obtain this transparent film, perhaps you have to add some additives or components that will not be easy to biodegrade in the future or to compost. So what is your opinion?
Yes, you're right. You're right. The packaging that we develop is translucent, it's not fully transparent, and that is an issue because we know that the customers, the retailers demand transparency so that they can see the product. But it is also true that it's an education issue. If you tell the people, so what do you want? To have a film that eventually will float into the sea as you are taking a swim with your family, or you want to maybe lose a little bit of the sense of what the product is in there, and then have a technology or a different perspective where this material will biodegrade, that will disappear in the environment. So this is a thing that needs to be considered. There are, of course, solutions that are transparent today, biodegradable solutions. And in fact, even more, within the project, we did develop into a very lab scale a grade of PHA that is fully transparent. But the thing is, this is not commercially available. So the versatility that PHAs offer in general is not being captured today by the existing commercial products. And this is, I think, why the importance of projects like a GLOPACK or our project, because we are developing these alternative ways of producing new family members within the PHA that will allow to not only overcome the issues related to transparency. For instance, we know today, I think there is a Japanese company producing some grades of PHA, and they are transparent. If you feel them, they are transparent. They have some other issues that need to be tackled. And for me, the ideal is that we have a broad range of PHAs available from different producers coming from different technologies, that by blending them together, then we will be able to replace, let's say, existing solutions. You still need to develop high barrier materials, but high barrier materials that are biodegradable are out there today. There is celluloses, there is starches, there is nanocrystals of cellulose films that we, for instance, have developed in the project. They are fully transparent. They are amazingly transparent, like glass. But again, you are right in that it was a big challenge for us, for instance, identifying what elements, what blending, what additives we could use within the project that would fulfill the same, let's say, a strategy of environmental biodegradability, which was our demand. That, and also food contact status to the extent possible. And today, we now know that there are solutions to that, and therefore it's feasible.
Okay, thank you very much. Another question, the idea of when PHBV will be available at industrial scale, 1, 2 years more?
Again, today it is commercially available. We have secured, for instance, production volumes up to 15,000 tons a year. So PHA is today available and can be used, and you just need to blend it because the current grades, they have a number of limitations. So 100%, a product made 100% of PHA commercially available is a big challenge today yet. So it needs to be blended, it needs to be compounded, it needs to be added with other components. So when will these new PHAs will be available? So this is our fight at the moment. There are several projects in which scalability has been proven for different technologies. And we've been part of those, including our project. We scale the production up to 0.5 ton capacity. But today, there are other plants that have been developed, like the project, the Smart Plant, and other sort of projects, in which this scalability is at the tipping point of what they're doing. And so what is the time scale for this to be commercially available? I mean, one of the technologies that I loved pretty much in production of PHAs is the one that uses municipal waste, sludge and the organic fraction of the waste as a feeding element, so that you can actually end up having in every municipal water treatment plants, etc., the same as we have today biogas plants, a PHA plant. So if this is the case, then we can replicate these plants in every municipality. We have calculated that that in any municipality with an excess of 1 million inhabitants, a plant will be commercially viable already with this quantity. So when will that take place? I would say within the next 5 years, but I think it's all about a matter of investment because the technology has been pretty much demonstrated.
Okay, so next question is regarding the LCA of PHBV. Did you performed some studies about that compared to other packaging, to other molecules?
Yes, in the GLOPACK project, our partners of University of Ghent have a close look at that. So they are still, as the project is still ongoing, they are still conducting their life cycle assessments. It will definitely be available at the end of the project. And what they really do is they have a look at the life cycle assessment of the PHPV-based packaging compared to the reference packaging, which means to the packaging that is currently used by the food manufacturers within our consortium. So as this is a quite complex assessment, of course, lots of data needs to be collected for that, but for sure at the end of the project for GLOPACK, there we will have really in-depth insights into that by University of Ghent.
In our case, if I can add my 2 cents here, we have just delivered the deliverable on life cycle analysis, where we actually have a very positive impact. So this we already anticipated for some time within the project. We have a company based in the UK doing that type of work, and they have been comparing the different materials, also different end products, formulations, etc., and they all come with a much better impact. And hopefully this now will be published in short, and or will be made, let's say, available. So the project, our project was supposed to end up in November, but due to the pandemic, we had a little bit of delays accumulated over the pandemic times. And eventually the project has been extended for an additional 6 months. So within that time frame, we are also intending to, let's say, make use of this extra time to release this information in different forms, hopefully webinars, but also papers, etc. But the answer is yes, we do have a positive LCA analysis compared to existing in our case.
Yes, LCA analysis is very important, I think, to prove that the environmental performance, I think. We do the same also in MyPack with the packaging we are providing. So another question about the crystallinity of transparent films. So normally amorphous films will be transparent in nature, but the mechanical properties may not be promising. Who wants to?
If I can answer, yes, the South view is correct. The crystallinity is a matter of not only crystals, because for instance, nanocellulose films that we have developed are fully crystalline, 100% crystalline, and they're still fully transparent. So it's not about amorphicity, but also about the packing density of the materials. But in general, I agree with the comment, and it is true that when we use, let's say, PHA grades with lower crystallinity, the transparency increases dramatically. And if you want to have a rigid film, then you probably need to do multi-layering as the solution. But in most cases, films require to be flexible, and not only flexible, but also shrinkable by heat and these kind of things. So transparency is interesting. It is true that by making the material less crystalline, you modify the mechanical properties, but more importantly, also the barrier properties, which I think are more relevant probably than the mechanical in flexible applications, where PHA in general has always been accused of being too brittle, and right now we are having materials that are very flexible. So this is amazing. This is really good. So we are breaking, let's say, the existing preconceptual ideas that many people have on that respect. So multi-layering with high barrier transparent polysaccharides, for instance, is a solution that works very nicely.
Okay, question from Didier Lanquetin. Regarding LCA beside PLA, there is no data in eco environment. Yes. Unfortunately, many bioplastic LCA from laboratories, university are too specific to be used in comparative LCA studies. Okay, so you want to precise your questions, please?
I also don't understand.
Hello.
Yes.
You hear me? Yeah.
Yes, very well.
Yeah, I'm doing some LCA with bioplastic. One problem in eco events, you only have PLA. So when you want to do a comparative study with PP, PLA, and PHB or PBAT, it's difficult to conclude, because sometimes it's like for PLA, it's a good data are quite good because they come from nature works. But sometimes when it comes from laboratories, universities, it's very specific formulations and processes. So it's difficult to compare a pilot scale and industrial scale on the same study. So it's one of the main problems. So we are looking, we're still waiting for industrial data for PHA, for example. But Mr. Lagaron, so you explained very well your product this morning, so it's fine.
Yes, thank you, Didier.
So, yeah, sorry for my English.
You're right. You're right. This is why I think GLOPACK has also done the LCA of PHA and into their solutions. But we also did, and we did that actually at an industrial scale. So we did consider all the processes that would lead to an industrialization. We have made assumptions for volumes, etc. So we have really made the effort to show that not in a lab environment, which is very often the case. I agree with Didier on that point. And we have also compared with PLA, etc. And I don't have the numbers at the top of my mind now, but this study done by this English company, KPD, is actually very good. So I'm looking forward to be able to show it very soon, because the deliverable has just been uploaded into our project participant portal. So this information will be cascading down very soon.
Okay, fine. It will be interesting to get the results. Yeah.
And regarding the adaptability into eco-invent, as I'm not an expert in LCA, if it's okay for you, I would get in contact with our partners in charge for the LCA and give them this as a question as well as an input to ensure that, or maybe ask what are the necessary steps in order to bring these kind of research results into this database. But I have to get back to my partners regarding this, but I will do so directly.
Thank you, Linus.
Okay, Mark, you precise in your presentation that for the packaging you are proposing, the new solutions, you are not changing. It's not you are using the same equipment, same than. So it's a good news. It's very important.
We have used.
But regarding training, do you need training effort to adapt to use the new polymer and so on?
Yeah, absolutely, Christophe. Yes. In fact, it's very easy, because you think that you develop technology that can be made, that can be processed with existing machinery. because we have been producing at a certain scale, at the tonnage scale. Then we have been conducting trials outside the project already with the bigger industries. And it's very funny because even if the same machinery can be used, the training issue is very important. The mindset of most operators is, okay, so if I've been used to process PET, naturally, even if you give them the profile of temperatures, etc., that you would expect, naturally they will try and use their existing, let's say, know-how. And very often it takes 1 or 2 days of trials to break that sort of, you know, to open their minds in a way, to allow them to think outside the box. But eventually we have proven that it works with existing machinery. And not only for cast extrusion and thermoforming, but also for lamination. Industrial lamination is being done within the project with different partners. And yeah, it's always the first trial. I mean, the first 1 or 2 tons are usually wasted. But training is important because suddenly you have new materials. People are not aware of certain issues related to their use. And even if you warn them, what I recommend for anybody who is doing this is to actually go and physically be there, because there is no way you can transfer this knowledge on a piece of paper.
And you, of course, you are taking in charge this transfer of knowledge.
Yes,
Your
we
institute
do.
or...
Yes, so we created a spin-off company that is doing the compounding at an industrial scale.
Okay.
And even producing some different products now, not only our packaging, we're doing straws, plates, other kind of things as a result of the work. Even masks for protection. Right now. We have created a company that is doing this kind of masks, and we're using all of this knowledge to transpose, let's say, our thinking of these bio-based materials, biodegradable materials, into everyday applications. And yeah, the knowledge transfer, although we have a partner in the project doing so, it is actually more important that we very often regard in the project, because it's not only training people at the industrial facilities, but also explaining well what are the advantages to retailers, etc. So education, dissemination becomes, I think, a challenge for some of our projects, especially when it's led by scientists, etc. That we're always thinking that people would understand very easily what we talk about, but this is not necessarily the case. So there should be, I mean, and these kind of events are very good. I really love webinars in a way, because that allows that more people can attend. Yeah, we kind of withdraw the physical element from the table, but in a way more people can attend and can participate, can make their questions, and by making those questions, we become aware of issues related to dissemination that we did not have in mind beforehand. So I love this kind of shows.
Okay, me too. So do you have any other questions? We are almost at the end. But if you love this kind of webinars, I just want to inform you that we are preparing another one, 2 ones in collaboration with the 3 projects. So Nawel, do you want to give us some information about these webinars in preparation?
Yes, regarding the participants who are interested on the application of LTA and LCC, I want to inform them that the next joint webinar with MyPack and GLOPACK will be on November. We didn't identify the date again. And the title is Under or Over Packaging, How to Find the Right Balance Between Packaging and Food Waste. If you can follow us through Twitter or our website for the 3 projects, you will have more information, and also we will contact you in order to give you more information regarding the registration of this webinar. You will have the link in the upcoming days. And for the last webinar, sorry, it will be on December. We didn't decide again regarding all the information, but you will be updated. Please try to follow us through our social media and website. Thank you very much.
Okay, thank you very much, Nawel. So if there is no other question, I think we can close this webinar, this very interesting webinar on bioplastics. And how the participants can get the presentations?
We will contact them in the upcoming days.
Okay, so you have all the email, contact details. So you will receive the presentation by in the next days. Okay, so thanks. I want to thank first all the speakers because they did a very, very nice, very clear presentations on the topics that it's not very easy sometimes. We got a very nice overview of the situation now, of the outputs of the two projects, the three projects, MyPack, GLOPACK, and YPACK. And of course, I want to thank Nawel and all the team from YAM, from Siam Bari, for the practical organization of this webinar, and I will be happy to see you again for the next ones. We are organizing in collaboration together with the three European projects, MyPack, GLOPACK, and YPACK. So thank you very much, and have a nice day.
Thank you
very much.
Yes.
Goodbye, everyone.
Thank you so much. Bye.
Ciao, ciao.
Bye.
Goodbye.
Bye-bye.